So, friends, right now we invite you to Yandex. Tolokia, Roman Gaev is going to tell us about crowdsourcing from Yandex Toloka. Everyone, hello. My name is Roman Gaev, and I'm Customer Success Manager at Toloka. And today I wanted to talk you through a few business cases that we do at Toloka on that data capture. And I hope it will inspire you to use crowdsourcing as well to capture data and to label data. A few words about us. What is Toloka? Toloka is a crowdsourcing platform to label data, and we used to be a part of Yandex starting from 2013. First, we were applied for internal purposes, and in this case, throughout this time, we have gained a lot of experience. And now we're working on an international project with Yandex, and we work with other clients from abroad and with top technological businesses from the Valley and from Asia, and with many other businesses and startups. And just a few words about myself. I was analyzing data. I was doing machine learning at Sber in the beginning, and now I help clients of international Yandex Toloka to put together and to launch data capturing and the data labeling. So let us talk about data, how important are data for every AI startup and AR business, and whether it's a key competitive advantage now within any business if we speak about AI. And I also will show some industry cases that I worked on when at Yandex Toloka. And also I will tell you how we capture data with the help of the crowdsourcing, why it works faster, more efficiently, and why it's more scalable. To begin with, wanted to emphasize that data is one of the main selling points in AI business, and it makes your product much better than the product of your competitors. I will not dwell upon this slide for too long because everyone has known about it for a long time. We spend about 80% of our time for managing data and analyzing data and preparing data, especially if data are not compiled well enough. We all know the theorem of data chain and data chopper. Now AI is built on three pillars: algorithms, hardware, and data. Two first algorithms have already been worked through in our case, algorithms and hardware. Then the last pillar, data, is still quite a great spot. It hasn't been defined yet. There are a lot of libraries, a lot of hardware is available to everybody. It depends on your wallet, of course. But all these services are available. They're accessible. As to data, data are a unique part still, and they can become your selling point for your product. And as funny it is, in Kaggle, you compete with a given data set, and you compete for some shares of accuracy. But in real world, we all compete, first of all, with products. We compete with value that we bring to users, and we also compete with the whole ML pipeline, including data that we're using and data management that is working on the project. So startups where businesses are going to use, where businesses are using their data in a better way, they're going to win. Another irony here is that almost all the ML-based solutions require human assessment in order to do some automation. We need to apply manual work in the beginning. And if there is a large scale, then we need to have a lot of assessments from different people, a lot of humans labeling. And if you look at any ML pipeline, if you look at life cycle of any model, then people are present at every stage. At training and validation, human validation is there, validation in production, some offline matrices, or some other approaches where we make the model more confident. And when we are retraining on more fresh data, Right now, it's being done very fast, and receiving fresh data, this is what determines success of the product. So where do we get the data from? We can use open source, but in this case, we don't have any advantage compared to our competitors because these data are just available to everybody. We can buy data, but it's costly. We can receive data with the help of a lot of distributed users, with a cloud of distributed users. This is crowdsourcing exactly, and we believe in crowdsource actually. You also can get data from your users, but it works only when you have a large product and you have a lot of data that users generate, for instance, logs or some user stories. You can parse this data, parse for it. It sounds simple, but actually parsing is such a labor-intensive process, and a lot of things are blocked, and maintaining parsing constantly is quite difficult, and it requires a lot of effort. Or you can get data from your partners, but it's also it questions your independence. As I said, no matter what source of data you use, no matter where you get them from, anyway, they're from real people, and real people are behind all of this data. And in the majority of cases, people are behind of any automation. And many believe that it looks this way, like a nightmare, where people, thousands of people, are sitting by each other and they're labeling tasks in one large room or in some basement or in some warehouse areas without a chance to leave the room, locked most probably, so that they don't escape. And we believe that actually you can make sure that the cloud is not distributed, and every executor can take tasks and label them at any time when he wants to do so, and where they want to do that. And they can choose the quantity they like, and they can use their personal skills. For instance, if the user, if labeler has an expertise in medicine, then he can label, for instance, some medical documents. Distributed cloud and open platforms, this approach, open source platform for clients and for those who collect the data, then we can create a flexible market where clients provide the data and labeling and choose the best labelers, and talkers select the best and the most highly paid out of these tasks. And if you use this approach, we have already proven scalability and efficiency of this approach. We have used it in all Yandex approaches. We did it for Yandex search engines, and we used it for self-driving and for voice assistants such as Alisa. So it's great that every product, to some extent, is efficient, partially due to Toloka. Toloka contributes to the success of all these products. Now let's have a look at use cases. I hope they will inspire you to do something similar, where crowdsourcing can be applicable, where it will be cheap and efficient and fast. I would split these use cases into 4 main clusters that our clients usually use, because we keep on labeling a lot of projects for our clients, and we see which ones of them can be bundled. First, data collection. When you don't have data to be labeled, and data are collected, either images are collected or videos get collected, or geographical data, or labeling, data labeling. So if you already have data, they need to be labeled. The third cluster is business decision making. This is where decisions need to be made to support the product, either surveys or questionnaires or side-by-side comparisons. This way, we even were choosing the solution for Toloka. It's a spoiler. I will tell you about it later. And the fourth cluster is human in the loop. When we need human expertise in order to validate the model, for instance, or we need human expertise to label data with a low level of confidence. Let's have a look at the first cluster. It's data collection. One of most frequent cases is data collection for voice assistant. Every business believes that it has to launch a business assistant of its own, and Toloka, the distributed cloud of labelers or executors that's available in different spots of all over the world. You can do it in different languages as well. For voice assistant, you can do it in English, in Russian. You can double check them. You can check grammar in these voice messages and many other things. This is not all. You can also collect data. Instead of parsing, you can monitor a competitor's website. You can collect data from online, from websites. And this is much faster rather than parsing. And oftentimes, businesses monitor the value of their competitors, both marketplaces in e-commerce. For instance, clients come to us oftentimes and do this in Toloka. Another great case for e-commerce, I guess you have seen that on Yandex Maps you can see working hours of businesses, when a shop works, what are business hours, what are working hours of businesses or shops or restaurants. It all is done with help of Toloka. On Toloka, you can see that you will see a lot of tasks in real-world time, in real-time mode, and you can take a picture of a restaurant or an organization and indicate working hours. This is what it looks like. E-commerce cases more. You can also monitor a situation on the shelves of stores. It may be a lack of product or availability of product on the shelves, whether they're there or not, whether the store is clean or not, whether shelves are clean or not. You can control it. Let's take example from a startup. It's a great startup, Nitsi. They're doing online fitting rooms. They have collected 1,500 videos for fitting rooms. This is their case. They created an app to try on shoes on your feet. They collected 1,500 of videos, and they split it into 50,000 images, and it took only 5 days and $75. Earlier, they tried to do it through their friends, and it seems that that way, through their friends, they wouldn't be able to do it that fast and that cheap. Another cluster of tasks is data annotation or data labeling. We already have data. Let's begin with specific example. It may be simple segmentation. It may be simple segmentation or 3D marking or annotation for cars. Audio transcription. This is an often case for switch-to-text models. We can transcribe different messages into text, and we can train models this way. NLP-related tasks, first of all, it's recognition of types. Just a second, hold on a second. Yes, this is labeling of named entities. There are businesses that come to us and ask to mark or label entities into product, brand, model, and it helps them do the work more efficiently. We also had a client who would take product reviews, users' product reviews, their reviews on the marketplace, and after that they would highlight positive and negative reviews. It was a great case for models as well. We have a huge cloud of executors. They speak different languages, and this is great, and this is why we can use Toloka for translations as well. For instance, Yandex Translate uses it to validate its changes into models and in order to understand what translation works better and what translation works poorly. We compare translation pairwise. We search for grammar mistakes among native speakers and Tolokers that speak different languages. And we have more. On Toloka, you can place information in real-time mode, and our executors are located all over the world in different time zones. You can moderate comments. you can give a task to talkers to verify comments, whether there is a spam in the comments or insults in the comments. It works great as well. Another use case, training data business. They label 34,000 images from Japanese TV. Of course, we replaced the pictures. These are not the real pictures, because these were data of our clients, but this is approximately what it looked like. And 65,000 faces were labeled in 3 weeks, and $0.15 per face was spent. 34,000 images. I think it's great. Now let's product decision making support. This is another cluster of tasks that we resolve. What's ironic here? Toloka, with the help of Toloka, helped to change branding, helped to change identity, helped to change the logo itself. I will give you more details about it. And now let's have a look at what other use cases can be here. First of all, first use case is data collection from users. It might be classification of your request for different intents, intent classification, the analysis of the tone of your request. It can be a questionnaire or a survey. If you want to learn more about your audience, Toloka has a lot of different filters out of which you can use, starting with social demographic tasks, ending with filters related to Talokers and employment of a Taloker. So you can do some tests. And let's get down to our use case. This is our own use case, our brand identity. Our designers brainstormed 5 main hypotheses. What logo could be better for us, because we had a large-scale rebranding when we launched ourselves to international market, to global market, and we came down to 5 main logos that we were considering, and we decided to give it to Talokers to listen to them. First of all, we can check whether there is an understanding, whether there is any negative something negative about a logo that people will feel. We might not feel it, and maybe some of our logos might be similar to other logos. The first logo, for instance, people told us right away, the Talokers told us right away that it's similar to another business. Many of you might recognize it as well. And the final logo, this Dindelian, here we received more than 1,500 Talokers labels. We did it side by side. It was pairwise comparison, and we received a lot of results in 6 minutes. It cost us only $1.50, so it cost us $1.50 to choose a new logo. How to reach this speed? How to reach these results in terms of speed and price? The consortium is based on 6 main pillars. First, decomposition. It's the heart of crowdsourcing. This is the most important thing. Any task, no matter how complex it is, it can be solved with the help of crowdsourcing if it's decomposed to a lot of simple parts and if it's exposed to a cloud of non-expert executors. We work with digital technologies, and it all is based on some binary things. Distributed conversion cloud. To some extent, Talokers are exactly this. We give them simple tasks. They handle these tasks fast, promptly, and easily, and then we can bring it back together into one big solution. Second is instructions. If the instruction is simple, if the guidance is simple, then any Taloker can handle it. Maybe you will need to hire a group of experts who can do it much more slowly and much more expensive. Third, interface. In Taloka, we use simple interfaces that save time for Talokers, and they help obtain fast results. Talokers expect payment based on a certain rate per hour, and the more tasks they perform per hour, the cheaper the result is. This is why interfaces are contributed into quality, into value, and into speed. 4, it's quality control. Of course, all the people are lazy. It's typical of all people to be lazy. If you don't control the result, then the data will have a lot of noise. This is why we have very smart processes, smart things that control the quality. Overall, Toloka is about mathematics as well and about verifying the results, and the opinion of a few Tolokers is important. This is point number 6, actually. We apply internal points. This is the heart of Toloka, the second heart of Toloka, on top of decomposition. We take a few opinions of a few Tolokas, and based on their skills and based on their performance on other projects at Toloka, we can aggregate it into result with higher probability. More securely, we will get higher quality. It's going to be better than asking an expert who can make mistakes as well. And that's actually it from me. And in conclusion, I just wanted to say once again that data is a competitive advantage. Your data that you have, is your competitive advantage nowadays. In case if you have other conditions equal, then data will help you stand out. Second, it's crowdsourcing. Crowdsourcing is a tool. It's such a tool that will help you label data. Of course, it will not sort out all the problems, but it will help you label a large amount of data in a very short time and very cheap. And the third point, the third takeaway, is that Toloka can become an instrument and methodology to collect data, to place data, to label data with the help of crowdsourcing. I wanted to say that's it, but it's not it. It's not the end. We have an initiative for startups. We support startups. We provide grants for startups. We help them do pipelines. We help them place data efficiently. We have a huge database, a huge base of knowledge. So connect with us and come over. And we have a huge community of clients who work with Toloka, who cooperate with Toloka. They share their knowledge with us, share use cases with us, best practices, and how to launch products. It's great being here. Thanks for having me, and I'll be happy to answer your questions. Thank you very much as well, and we do have questions. A few questions. Confidentiality, data confidentiality that you are placing, how did you sort out this problem? First of all, data can get distorted. For instance, voice data, we change the data, we adjust them to protect them. For instance, if we speak about text, then you can split this text into tokens, you can depersonalize data, you can eliminate personal information, and then you label it, and then you assemble it back together. As I said, you can split data into tokens or into sentences, and then in this case, the context is lost, but this is the what you should do in order to depersonify data. Thank you. There is one more question. What difficulties might the business get faced with when it's using crowdsourcing? The advantage of crowdsourcing is that it's scalable, it's fast, and it's cheap. But in order to deploy it, you need to make some efforts. You need engineering efforts by the client in order to understand how methodology works, and primarily with these 6 pillars that are needed to understand crowdsourcing. Because oftentimes there are clients that come over to us and they don't have an understanding of how to mark, how to label their data. When an expert doesn't understand the data, you need to decompose the data correctly. It's very important to decompose the data correctly. Otherwise, it might go the wrong way. So engineering efforts by clients, on the side of clients, it's one of the potential problems. But in order to do that, to sort it out, we have Toloka apps, and it helps us. And in this case, we do it. If you don't have resources for that, you're welcome to come over and you can use Toloka apps, and we will sort it out. And thank you. And final question. Quality of the task. How do you make sure that the tasks resolved in a quality manner. A few approaches here. First of all, training. We train talkers. We test talkers, some exams. We do it on data with hidden values. We test talkers, we tag potential executors, and we assess their level. When executors join the talkers pool, when they start labeling your data, then once in a while we check their performance by sending them some secret tasks. The second type of quality control is post-checking. There are types of tasks such as voice messages for voice assistants. There, it's difficult to do some tasks with the values that are known in advance because these are voice data. In this case, we engage other talkers and we either accept the task performed or reject it. Thank you very much. We've exhausted the questions for you. Thank you very much for your brilliant presentation and thank you for your answer.